Hey, hello, welcome. I remain Prosper Nwangu. And in this week lesson, we're looking at hydrocarbon. For the last week lesson, we also looked at hydrocarbon. I told you that the lesson hydrocarbon is going to span for about 4 weeks. And in the last lesson, we looked at the introduction to hydrocarbons. We defined hydrocarbons. We defined the term catenation. We talked about terminology such as hybridization, and we discussed hybridization. For this week lesson, we're going to be focusing on the homologous series. Now, do not be scared. Don't let that name scare you. It's just a simple process. It's just a simple classification. We'll look at what the homologous series. We're going to focus on it. In fact, moving forward for the next 3 weeks, is going to be about the families under the homologous series or the homologous series in general. You may not see it as that, but that's what we're going to be looking at in general. So let's dive into the lesson proper. So our specific objective for the lesson, the first thing you should learn at the end of the lesson, you should be able to explain the homologous series. What is the homologous series? That is what a question you should be able to answer. And the second aspect, you should be able to define a functional group. Under the homologous series, you should also be able to state the characteristics of the homologous series. Now you should be able to define the word functional groups. We're going to be looking at these things. And thirdly, you should explain saturated and unsaturated compound. You should be able to tell me what are saturated compound and what are unsaturated compounds. And lastly, you state the first 10 members of the alkane families. Now this will help you understand organic chemistry or hydrocarbons as we advance. I repeat, if you've not seen the previous video on hydrocarbons, I want to ask you to pause this video right now or stop it. Go back to hydrocarbon, the first video, and look at it. Try to understand the introduction that I've been given there so you better understand this aspect. It gets deeper and deeper, not difficult. It gets deeper. If you don't understand the basics, it becomes difficult for you. So let's proceed. Let's dive into the first thing. Homologous series. So we have here a homologous series is a family of organic compound which follows a regular structural pattern in which each successive member defines its molecular formula by CH2 or a molecular mass of 14. Now this definition should be memorized. It should be memorized. This is a major WAEC definition. You should memorize this. Let me try to explain this further by way of using the characteristics of the homologous series. Now, the homologous series generally talks about a family of hydrocarbons. They are just like in your family, you may have your siblings. There's an age difference. Let's say your parents use an age difference of about 2. You may have yours may be different, but for most houses you might see a difference of 1 or 2. So there is a graduation in terms of age, and that is what the homologous series is all about. In a family, there are different families, and each family has a graduation where each successive member differ by a CH2 group or a molecular mass of 14. That is just what the homologous series is. You will need to memorize the definition. Memorize it. So what are the characteristics of the homologous series? So in this case, I'm saying what are the characteristics of a family? Now, using the homologous series as an example. So what are the characteristics of the homologous series? The first thing is they have the same functional group and the same general formula. It's just like saying they have the same father and the same mother. All siblings in that family have the same father and mother. But in this case, in regards to homologous series, all members of that family have the same functional group. I'm going to define what functional group is as we advance, and the same general formula. What other characteristics can we talk about? Second, they have similar method of preparation. And then the third aspect, they define the molecular formula by CH2 group. It's just like talking about the age. You define the siblings in a particular family will differ in age by a year or 2 years. So in terms of the homologous series, they differ in the molecular formula by CH2 or a molecular mass of 14. And fourthly, similar chemical properties and a graduation in their physical properties. So they may have the same behavior. Chemical properties and physical properties talk about behavior. measurable, and those ones that are evident during or after a chemical reaction. So they behave in similar way when you look at them in terms of the physical property. And for physical property, there's a graduation. So it may go, let's take for instance the states. It may go from gas to solid, a graduation in terms of a physical property. But chemical property are similar. What this can do, the other can do similarly. Moving on. What is a functional group? The word functional group. Functional group. Now, this functional group talks about a group. It could be an atom, a bond type. It can be an atom, group of atom, or a bond type that is characteristics of a particular compound that gives it its chemical property that determines what property it have. Let's say a functional group let's say you have this, you're fair in complexion. So that could be a functional group in your family. Let's say these persons are fair in complexion. So whenever someone says, you say, okay, this set of persons are fair in complexion. Let's say that is the characteristics of your family, and that is what basically functional group are. Maybe it's not a very good example, probably, but it's something similar to that. Let's look at the definition. We say a functional group is a group of atom or bond common to the series of organic compound and determines the chemical properties of that series. So determine the behavior of that series. Let's look at common chemical functional groups we have. Now, these functional groups are important. You would need them. You will need to know this functional group. Now, let's look at the first aspect. Let's go back to that, please. Going back to that, we have the alkane here. The alkane, their functional group, we have the alkynes. Now, the red sign talks about the functional group. You will need to pause the video and then try to understand the functional group. As we advance further, we'll talk about this compound one after the other, although we'll not exhaust them until SS3. We are going to stop at, for your SS1, we're going to stop at the alkyne. We'll talk about the alkane, which is not here, the alkene and the alkyne for the SS1 scheme of work, and we'll advance from alcohol going forward. And lastly, when we get to SS2, we'll talk about the amide. So do not be in a haste to know these functional groups. Do not be in a haste. You're going to be introduced one after the other. So these are functional group. For instance, in terms of alkene, the double bond here is the functional group. In terms of alkyne, the triple bond here is the functional group. In terms of alcohol, the OH here is the functional group. This is ethanol, so the OH is the functional group. This one's in red. These highlighted atoms are the functional group going downwards. So that's what functional group are. Group of atoms, a bond type that is common to a series of organic compounds and determines the chemical properties. You could have more than one functional group in a compound. It's not just limited to one. You could have about 4 functional groups as part of a compound. Moving on. Saturated and unsaturated compounds. And what are these? Now, from what we have in the past, stepping back forward again, pardon me. From what we have here, we have a double bond and a triple bond. So what are saturated and unsaturated compound? So saturated and unsaturated compound have to do with what kind of bond is present in an organic compound. For instance, if you see an organic compound containing just single bonds, all through single bond, it is referred to as saturated. If you look at it, the diagram, and you see it does not contain a double bond or the triple bonds. Judging from the tetravalency, the tetravalency of carbon does not contain double or triple bond, then it is a saturated hydrocarbon. Although, if it contains triple or double bond, it is referred to as unsaturated. As simple as that. Very, very simple. As simple as that. So you shouldn't find it difficult to define this when you see it in the exams. 2 marks for each definition. Simple. So let's look at the example of that. Looking at this is called saturated because all what we have here are all single bond. There is no double bond anywhere in this compound. Now going to the next one, we have a double bond on this between these 2 carbon atoms, and so it is referred to as an unsaturated hydrocarbon. In this case also we have a triple bond, so it is referred to as an unsaturated hydrocarbon. In the case of this aromatic, remember in our last lesson I said I'm going to refer you to the term aromatic. So this is benzene, the structure of benzene an aromatic hydrocarbon, it is referred to as unsaturated because there's a double bond. So it's as simple as that. If you see no double bond or triple bond, it is unsaturated, it's saturated, and if you see a double bond or a triple bond, it is an unsaturated hydrocarbon. So the alkanes. Now the reason I brought the alkanes into this, some teachers will prefer to follow the textbook in regards to how we go about teaching organic chemistry, but I think that would not work for many students. For a lot of students, it does not work. So I had to derive a new methodology to pass this. Now the alkanes form the basis of organic chemistry in general. I think the alkanes form the basis, and so it is important that the students understand the alkanes. We're going to revisit this as we continue, as we advance further, but I want you to understand the alkanes. You have a task to do here. Now we're not interested in, okay, we've seen in the past and previous slide that the alkanes are saturated. They only contain single bond. The alkanes are just saturated. And the general formula, we're not interested in the general formula right now. Although the general formula, the function of the general formula is it allows you to determine to write the structure of the alkanes, but you will not be needing it. At the end of the day, what you just need to know is to know the general formula. That the general formula for alkanes is CnH2n plus 2. As we advance further, probably I'm going to tell you how this can help you write the structural formula of the alkanes, or the condensed formula. And lastly, hybridization is sp3. In our last video, we talked about hybridization, the joining together of two or more orbitals of the same principal quantum number to form new set of orbitals that are degenerate. So the alkanes has the sp3, or the carbon atoms in alkane are sp3 hybridized. Now, why is this important? It's important majorly for JAM. You're going to be asked which of these structures, you may be shown structures or compound, is sp3 hybridized, or something like that, something similar to that. You'll be asked to identify the hybridization present in given compounds. So the alkanes are sp3 hybridized. When you see single bonds or two, when you see saturated hydrocarbons, if it's saturated, it is sp3 hybridized. You should choose that. As we advance further, we'll talk about the sp2 hybridization and the sp hybridization. So the members of the alkanes. Now, this is a task. You will need to memorize the members of the alkane by heart. Now, I noticed that a lot of you are still finding it difficult to recite the first 20 elements. That should not be said in the open. Now, if you are one of such students, please, I want you to go back and memorize the first 20 elements, not even using a memory aid. You may not even need a memory. You're of a higher class. You should be able to memorize the alkanes, the first 20 elements without memory aid. But if you need a memory aid, don't be shy to use it. But at the end of the day, you should be able to state the first 20 elements at least, or advance for that to 30 or even more than that. You would need that. So for the alkanes, this is something you will need to memorize for you to understand this aspect of chemistry, organic chemistry. Now the first member of alkane is methane, second is ethane, the third is propane, then we have butane, pentane, hexane, heptane, octane, nonane, and decane. I'm going to tell you why these are important. So we just have 10. It's not up to 20, we just have 10. You only need to memorize 10. You can pause the video and try to recite it. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And we have the structure. If you notice, they are all saturated. They're all single bond and sp3 hybridized. And this is the condensed formula for the hydrocarbons. And this is the molecular formula. The molecular formula, here's the structural formula, and here's the condensed formula. You're going to be seeing these types of formula, the type of formula as in your exams. So you should not confuse one for the other. They are all the same, nonetheless. So we have CH4 here, and it's also the same thing as the condensed formula, and the structural formula is open where you put show all structure. I also told you about the tetravalency of carbon in our previous video. Let me stress on that a bit. Now, if you notice all carbon atoms have going back to that, all carbon atoms are bonded by 4 bonds, has 4 bonds. This carbon atom is 1, 2, 3, 4 bonds, and each one, counting it, you can pause the video and count, all of them has 4 bonds. That tells you about tetravalency. They are covalently bonded. 4 for each carbon atom. So it allows you to know when you have the correct formula. So thank you very much. We have our assignment in the Google Classroom. For those that are in the habit of not doing assignment, remember this is part of your continuous assessment, and so do well to do this assignment. It enables me keep track of your progress and helps me know when to revisit certain topics so you better understand. If you have any question, do not hesitate to ask me in the Google Classroom or through WhatsApp platform, my email. I have a lot of means you could reach to me. We have the email, we have the Google Classroom, we have the Zoom, and we have WhatsApp. But majorly, I want you to bring forth your questions to the Zoom class, our Zoom class, and ask any question you have on the topics we've treated so far for the week. You ask your question and I will attend to them. Thank you very much and do have a nice day. Stay safe.